Under the title Acids, Bases and Salts, today we are doing salts. Acids and bases were done in the earlier videos. Today I am going to tell you about salts. What are salts? Okay. Salt is a compound which on dissociation furnishes a positive ion and a negative ion other than hydrogen ion and hydroxyl ion. That means the positive ion is not H plus ion and the negative ion is not OH minus ion. For example, if you take NaCl, sodium chloride, on dissociation, it gives Na plus ion and Cl minus ion. Okay. So this is cation and this is anion. This cation is other than H plus ion and this is other than OH minus ion. Okay. So this is definition of a salt. Salt is a compound which on dissociation furnishes a positive ion other than H plus ion, a negative ion other than OH minus ion. Now there are different types of salts. This is a salt. Another example, you can take Na2SO4 sodium sulfate. It will furnish 2 Na plus ion and SO4 2 minus ion. So this is a cation other than H plus. This is an anion other than OH minus. So this is what a salt is. There are different types of salts. You have already learnt in acids, bases. While teaching basicity and acidity, I taught you about normal salt, acid salt and basic salt. Okay. So first one is normal salt. What is a normal salt? You all know, but once again I will explain. A normal salt is formed by complete replacement of replaceable hydrogen ions of an acid by a basic radical or a positive ion. Okay. For example, if HCl, now in this HCl molecule, there is only one replaceable hydrogen ion. Okay. If this ion is replaced with the help of a positive ion or a basic radical, then the salt which we get will be a normal salt. So if it reacts with NaOH, it will give you NaCl plus H2O. This is neutralization reaction. Okay. So this H plus ion is replaced by this Na. Okay. So this Cl is combining with Na and H is combining with this OH. So ultimately NaCl and H2O. Now look at this formula of NaCl. There is no more replaceable hydrogen ion present in this. Only Na and Cl. Okay. So this is a normal salt. So this kind of salts, there are number of examples. So depending upon the acid, which acid you are taking, the types of salts will be formed. So with the help of H2SO4 or sulfuric acid, we get salts like Na2SO4, K2SO4, CaSO4, MgSO4 and so on. Okay. With the help of HCl, hydrochloric acid, you get NaCl, KCl, MgCl2 or CuCl till CuCl2, you can write any one. Okay. With carbonic acid, you will get carbonates like H2CO3 will give you carbonates. Okay. With the help of nitric acid, if you are using nitric acid, then you will get nitrate salts like sodium nitrate, potassium nitrate and so on. Okay. So here is a number of salt. With acetic acid, we get acid salt. So this, look at any of this formula. Here, there is no replaceable hydrogen ion. So this is a normal salt. Okay. Second set of salt, second type of salt are acid salt. Okay. So the acid salt, in the formula of the salt, you will find that one or two replaceable hydrogen ions are still there. So acid salts will be formed given by dibasic acids or tribasic acids. Okay, because monobasic acid will have only one H, so this will be replaced in the first step. So there won't be any H in the formula of anion. So H2SO4, if reacts with KOH, it will give KHSO4 plus H2O. Now look at here. Here, out of these two replaceable hydrogen ions, only one is replaced, okay, and that one H is combined with this OH and has come out in the form of H2O. Now, one H is still there. The anion, what was the anion? HSO4 minus, okay. With the help of this anion plus this K, together we got this KHSO4, potassium hydrogen sulfate. So, still one more H is there which can be replaced. So, this type of salt is called as acid salt, okay. So, like this you can get NaHSO4. These are hydrogen sulfate salt. If you are, there are other examples, carbonate salt, NaHCO3, sodium hydrogen carbonate, or potassium hydrogen carbonate can also be written, or KHSO3, sulfide, potassium hydrogen sulfide. So these all are acid salts where still one replaceable hydrogen ion is there. Okay, so the next set of salt or type of salt is, third one is basic salt. Third one is basic salt. What are basic salts? Basic salts are formed with the help of bases which have more than one hydroxyl ion. That means diacidic or triacidic bases. Okay. So for example, if CuOH2, this is copper hydroxide. This copper hydroxide has two hydroxyl ion. If this copper hydroxide reacts with HCl, acid and base, undergoes neutralization, one of the OH will combine with this H and come out in the form of water. So first step, if it goes like that, so one will be still left behind, and this kind of salt is called as basic salt, and name of this salt is basic copper chloride. Now if this basic copper chloride further reacts with one more HCl, then this OH will combine with this H. So the second hydroxyl ion will also be replaced. So you will get a normal salt. So this is what basic salt. Okay. Similarly, CuOHNO3 is written, then it will be basic copper nitrate. Okay. Or even lead can also give this kind of salt. So these are called as basic salts. After basic salt, you have double salts. Okay. So the fourth one is double salt. What are double salts? Double salts are formed by crystallization of a mixture of saturated solutions of two salts. Okay. The example, like two salt solutions are prepared, two saturated solutions is, both are mixed and they are subjected for crystallization. So crystals will come out after some time after crystallization, and that kind of salt is called double salt, and this salt will be associated with some number of water molecule, water of crystallization. The example of double salt, potash alum. What is potash alum? It is also called as fitkari in local languages. K2SO4 dot Al2SO4 whole thrice dot 24H2O. Okay. So this is a double salt of potassium sulfate and aluminium sulfate. So a mixture of saturated solutions of potassium sulfate and aluminium sulfate, when undergo crystallization, transparent crystals are formed. You can white transparent, or you can call it colorless also. These are potash alum crystals. Another example is more salt. More salt, light green color crystals. This is FeSO4 dot NH4 2SO4 dot 6H2O. This is also a double salt which is prepared with the help of ferrous sulfate solution and ammonium sulfate solution subjecting for crystallization. So this kind of salts are called as double salt. Okay. After double salt, you have mixed salts. Now mixed salt is a salt in which the number of cations or anions will be more than one. So the fifth one is mixed salt. Either two cations, one anion will be there, or one cation and two anions will be there. So like sodium, potassium, okay, phosphate. Here two cations are there and one anion is there. So this kind of salts are called as double salt. Even bleaching powder comes under this, which has two anions and one cation. Sixth one is complex salt. Now what is a complex salt? Like double salt, it is also like double salt. It is also prepared by crystallization of saturated solutions of two salts. And the difference is that it gives two types of ions when it breaks down. One simple ion and another complex ion. The example of complex salt can be like K3 FeCN6. What is this? Potassium ferricyanide. K4 FeCN6. This is potassium ferrocyanide. So they give ions K plus ion plus FeCN6 ion. Yes, ferrocyanide ion. And this will give potassium ion and FeCN6 ferricyanide ion. So they say these are simple ions and these are complex ion. Like this, sodium argentocyanide is another compound which is also complex salt. So there are number of examples. So this is what complex salt. So this is all about types of salt. After types of salt, you have solubility of salts or bases for water. Solubility is very, very important. Okay, solubility of salts or bases for water, with respect to water. Okay, so whether the given salt or base is soluble in water or not. So which salts and bases are soluble in water, which are insoluble in water, the table is given in your book. This is what I am going to teach. All the salts or all the compounds, all the compounds of sodium, potassium and ammonium are soluble in water. That means any potassium compound, sodium compound and ammonium compound will be soluble. There is no insoluble compound for these three. Okay. So then comes, first we will see oxides. Oxides of different compound. Maximum, whatever the tendency of maximum oxides, I will write here, and minimum I will write as exception. Okay. So all the oxides are insoluble. All are insoluble except, here I am writing exceptions, except sodium and potassium. Sodium and potassium oxides are soluble in water, remaining all are insoluble in water. Okay. Second, we will see hydroxides. Hydroxides which are soluble in water are called alkali, otherwise they are called as bases. All are insoluble, means maximum, except sodium hydroxide, potassium. Here you can write sodium oxide or potassium oxide also, Na2O, K2O also you can write, or Na plus and K plus also you can write. KOH, NH4OH, except these three. So these are soluble, remaining all are. If you say calcium hydroxide and magnesium hydroxide are sparingly soluble, so you don't get clear solution. Okay, so we don't write them as soluble, so only these two give clear solution, and ammonium hydroxide is also an alkali. Third one, carbonates. Now metal carbonates we are talking about. All are insoluble. All are insoluble. Again exceptions. Here Na2CO3, K2CO3 or NH4,2CO3. So sodium, potassium and ammonium carbonates are soluble. They are soluble. Remaining all are insoluble. Sodium, potassium if you leave, then comes calcium, magnesium, aluminium, all the carbonates are insoluble. Then fourth one comes sulfides. What are sulfides? Sulfides are almost similar to carbonates. Okay, this is CO3 2 minus ion, this is SO3 2 minus ion. They all are insoluble. Again same soluble except sodium sulfide, potassium sulfide and ammonium sulfide. Okay, so sodium, potassium and ammonium sulfide. After this you have fifth one, sulfides. What is sulfide? S2 minus ion. So fifth one is sulfides, metal sulfides. All are insoluble. Now what are the exception? Again sodium, potassium and ammonium. Okay, these are exceptions, remaining all are insoluble. So they are soluble, these are insoluble. Sixth one, after sulfides you have, now till here we have studied maximum are insoluble except these three, or for oxides too. Now comes where maximum are soluble and there are few exceptions. Okay, so we will start with that. Chlorides, metal chlorides, all are soluble, maximum are soluble, so we are writing all are soluble, and the exceptions are, I will be writing exceptions over here, except which chlorides are insoluble, do you know? Hg2Cl2, AgCl, you know, divide precipitate of silver chloride, and PbCl2. Okay, now this PbCl2 has a different kind of property. This is insoluble in, when we are talking about solubility, means solubility in water at room temperature. Okay, so room temperature water, PbCl2 will be insoluble, but in hot water this is soluble. So soluble in hot water. So what happens if you take PbCl2 and put it in water, it will not dissolve. If you heat, it will dissolve. And once it comes to room temperature, again it will precipitate like white needle-like structure. So this is soluble in hot water but insoluble in normal room temperature water. So these are three exceptions. Then after chlorides comes sulfates. Now sulfates are also maximum are soluble, all are soluble. Few are exceptions. The exceptions are calcium sulfate, barium sulfate, lead sulfate, PbSO4 and aluminium sulfate. These four. Okay, these are insoluble, remaining all are soluble. So sulfates are done. Now the last one is remaining, which is nitrates and nitrites. NO3 1 minus, NO2 1 minus. Okay, so the nitrate and nitrite compound all are soluble. All are soluble. No exception, none of them are insoluble. So for any metal nitrate, any metal nitrite you take will be soluble in water. So this is what about solubility. So we started with all the compounds of sodium, potassium, ammonium are soluble. So any sodium, potassium, ammonium compound, without any hesitation we can make solution in water. Okay. When comes oxides, sodium and potassium oxides are soluble. Hydroxide, sodium, potassium, ammonium are soluble, remaining all are insoluble, even oxide except sodium, potassium. Ammonium will not have oxide. Then carbonate, sulfide, all are insoluble except sodium, potassium and ammonium. Okay. Chloride, all are soluble except this mercurous chloride, silver chloride, lead chloride, which is soluble in hot water. Okay. Then comes sulfate, all are soluble except calcium, lead, barium, lead and aluminum sulfate. And nitrates and nitrites all are soluble. Okay. So this is all about solubility. This video is all about preparation of salts. Under that, preparation of soluble salt. You know, there are two types of salt, soluble, which are soluble in water, insoluble. So we will do them separately. How to prepare soluble salt, I am going to teach you. Now, to prepare soluble salt, we are starting with a soluble substance. So we are preparing soluble to soluble. So the substance which we are taking as the reactant is also soluble in water, and the product formed will also be soluble in water. Okay. So this one is by the action of dilute mineral acid. And what are mineral acids? Hydrochloric acid, sulfuric acid, nitric acid. These are common acids which we use maximum. Okay. So by action of dilute mineral acids on soluble hydroxides and carbonate. Now which are soluble hydroxides? Sodium, potassium and ammonium. Okay. Soluble carbonates also sodium, potassium and ammonium. So basically by this method we are preparing compounds of sodium, potassium and ammonium. Okay. So the first one we will take soluble hydroxide. So if we take sodium hydroxide, which is soluble in water, so we will get an aqueous solution of it, plus dilute mineral acid. So let us suppose we are treating it with sulfuric acid dilute. Writing this term here is very, very important. For these mineral acids, dilute acid properties are different and concentrated acid properties are different. They give different reaction with different substances, same substance also. So writing this dilute is very, very important. So NaOH, basically this is neutralization reaction. So what is the method of preparation? Neutralization. Okay. So NaOH will combine with H2SO4 and form Na2SO4 plus H2O. Now this is also soluble. Yes, this is also. So this is 2. So sodium sulfate is formed, which is a soluble salt. Similarly, if you treat sodium hydroxide with hydrochloric acid, we will get sodium chloride. Nitric acid, then sodium nitrate, provided you are taking them diluted form. Another one you can take as ammonium salt also you can prepare. Like if you are taking ammonium hydroxide, instead of sodium hydroxide, we are taking another hydroxide and treat it with sulfuric acid or nitric acid, then it will give its salt NH4 2SO4, which is aqueous, plus H2O. So this is aqueous, that is liquid. So this ammonium hydroxide will give ammonium sulfate. If nitric acid, then nitrate. Although ammonium nitrate is not stable, so we hardly use. We don't write that equation. Hydrochloric acid we can write, so ammonium chloride can be opted. Okay. So this is how soluble salt is prepared, starting with a soluble compound. Soluble compound is hydroxide. First we have taken hydroxide. Now let us take carbonates, soluble carbonates, and treat them with dilute mineral acid. So the same method, metal carbonates are also basic in nature. So that will be also neutralization reaction. Okay. So Na2CO3 aqueous plus or dilute mineral acid. Any dilute mineral acid we will keep on writing. First one, we are starting with H2SO4. So Na2CO3 we are treating with dilute mineral acid. What is dilute mineral acid? Which one we are taking? Let us suppose we are taking HCl. So it will give you 2NaCl. Now, here you see this Na is combining with this Cl and forming NaCl. What is left behind? This anion and this cation. So, maximum time when you write equations, commonly write H2CO3, thinking that this is H2CO3. But you are not supposed to write H2CO3 as this byproduct or the second product. This H2CO3, technically it will form, but this is very, very unstable. So what will happen? It will break down and give H2O and CO2. Okay. So this is what the reaction is. So sodium carbonate, if treated with hydrochloric acid, and what is important here to write? Dilute. So it will give sodium chloride, water and carbon dioxide. If we are taking ammonium carbonate, NH4,2CO3, and treat it with dilute sulfuric acid, then it will give NH4,2SO4 plus H2O plus CO2. So this is the small thing you have to remember. When carbonates are treated with dilute mineral acids, the byproducts are H2O and CO2. Instead of H2CO3, you write like this. Okay. This is how we can prepare a soluble salt, starting with soluble hydroxide or soluble carbonate and treating them with dilute mineral acid. So soluble to soluble. Let us suppose we have some insoluble substances. Then how to prepare soluble salt, and which soluble salts can be prepared, because all the oxides and hydroxides and carbonates are not soluble in water. So what about those hydroxides or carbonates or oxides which are insoluble in water? So then also we can prepare a soluble salt. So by the second one is by the action of dilute mineral acid on insoluble oxides, hydroxides and carbonates. Okay. So insoluble oxide, hydroxide, because it is acid, so insoluble substance will also react. For example, if you are taking FeO, which is insoluble, and treat it with H2SO4 dilute, then it will give FeSO4 plus H2O. Now this is insoluble and this is soluble. So starting with insoluble compound, we are preparing a soluble salt. So preparation of soluble salt, starting with insoluble oxide. Insoluble hydroxide also you can take, like PbOH2. Now here you have to remember one thing. For lead, there is only one compound which is soluble. So whenever you are writing an example for preparation of soluble salt, starting with a lead compound, the acid has to be HNO3. Okay, because if you take H2SO4, it will be sulfate, and there is a rule, you cannot prepare insoluble starting with insoluble. Okay, so that will be taught later. So it will give you PbNO3 whole twice plus H2O. Okay, this is soluble. So insoluble to soluble. The third one, we can take insoluble carbonate, like any carbonate, iron 2 carbonate or calcium carbonate or any other carbonate, FeCO3 or CaCO3 or CuCO3, anything till CuCO you can take. Treat it with dilute acid, hydrochloric acid. This time I will write hydrochloric acid. Okay, so HCl, dilute hydrochloric acid, it will give FeCl2 plus H2O plus CO2. So this is how. Again see, CO3 is there, that's why the byproducts are H2O and CO2. So this is how this insoluble, this is insoluble and this is soluble. So insoluble to soluble by the action of dilute mineral acid. This is second way of preparing soluble salt. Okay. The third way of preparing soluble salt, you all know this. You in 8th standard and 9th standard you had hydrogen chapter, in which general methods of preparation of hydrogen, active metals by a reaction between active metals and dilute mineral acid. Okay. So that is this one, by action of dilute mineral acid on active metals. What are active metals? In the metal reactivity series, you all know, starts with potassium. Okay, potassium, sodium, calcium. So in between hydrogen comes. So above hydrogen, so this is how you write potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold and so on. So all the elements which are above hydrogen can displace hydrogen from its compounds. Dilute mineral acid is compound of hydrogen. Yes. So the reactivity decreases if you go down. So all which are above hydrogen can displace hydrogen from dilute mineral acid. Okay. But when you are writing here the reaction, you have to understand which soluble salts can be prepared by this method or which examples can be given. You are not supposed to take potassium, sodium and calcium because these three are very reactive and their reaction will be explosive. So they are not taken into consideration or that reaction is not performed. Now comes magnesium, aluminium, zinc and iron. These are moderate. Okay. With lead, again insoluble compound will be formed. So you can prepare magnesium, aluminium, zinc or iron salts by this method. So if you treat magnesium with dilute H2SO4, dilute, okay. So what will happen? Magnesium being more active than hydrogen will kick off this hydrogen or replace this hydrogen and it will combine with this. So hydrogen will come out. So we write MgSO4 and hydrogen with there in hydrogen chapter, that was the significant compound, so we used to pay attention to this. But here we are preparing salt, so look at this. So this is a soluble salt. So this is active metal, dilute acid and a soluble salt, because you know magnesium sulfate is soluble. Okay, so magnesium sulfate is formed. Now similarly, if you want to prepare any other, let us take aluminium, treat it with HCl. It will give AlCl3 plus H2. So this will be 2, 6. So 2 and 3. Okay. So aluminium chloride is formed. Zinc, which is common in laboratory preparation of hydrogen. These all are dilute acids. Okay. So it will give ZnSO4 plus H2 and Fe. If you treat with HCl or H2SO4 dilute, FeCl2 plus H2 plus H2. This is iron 2 chloride. Okay. You cannot prepare iron 3 chloride by displacement method. You can prepare iron 2 chloride. Iron 3 chloride method is different, which will be taught in the next one. So this is how soluble salts can be produced or prepared using active metal and treating them with dilute mineral acid. Next method of preparation of soluble salt is synthesis, direct combination or synthesis. You know what is synthesis? Combination reactions, we know only one product will be formed. Okay, two some reactants, but product will be one. But when these reactants are metals, two metals combine and form one compound, then it is called as a synthesis reaction. Okay, so the fourth one is by synthesis. This way you can prepare in aluminium, zinc, or iron chlorides. Here you can prepare only chlorides because two elements have to combine. So the metals are heated and dry chlorine gas is passed over them, and there the reaction takes place. So aluminium Al plus Cl2 will give you AlCl3. Okay, so this is by heating to hot metal and pass chlorine, and then it will give you AlCl3. Zinc, you pass chlorine gas, you get ZnCl2. Okay. Similarly, iron is heated and chlorine gas is passed, then you get FeCl3 here. So look at here, here you are getting iron 3 chloride. So this is the way iron 3 chloride is prepared. So this is the fourth method of preparation of soluble salts. Okay. So soluble salts can be prepared by neutralization, soluble compound to soluble salt. Another method of preparation is insoluble oxides, hydroxide carbonate treated with dilute mineral acid. Then displacement reaction, active metal treated with dilute mineral acid. And the last one is synthesis, where metals are heated and chlorine gas is passed and you get this compound. So this is all about preparation of soluble salts.